For almost as long as people have looked up at night, the same small instruction has been passed down from one generation to the next. If you see a star fall, make a wish, and do it quickly before the light is gone. Nobody really had to teach you to feel it. The moment a streak of light slips across the dark, something in you gets stirred up. You want to say something to it before it's over. It is one of the oldest reflexes we have. And almost no one, in that half-second of wonder, stops to ask what they are actually wishing on, because it isn't a star. It never was. The thing we call a shooting star is, more often than not, smaller than a grain of rice. Some are the size of a pea. Many are no bigger than a speck of sand. That tiny piece of grit drifting in the cold dark between the planets is the entire object. What turns something that small into a blaze across the whole sky is speed. It meets the top of our atmosphere moving at around 59 kilometers every second. That is roughly 130,000 miles an hour. At that speed, the grain doesn't gently burn up the way a coal does in a fire. It slams into the air so violently that it tears the air apart. In the process, it strips electrons off the molecules in its path and ends up leaving a glowing wake of shredded, superheated atmosphere strung out behind it. So the light you see, the star you wish on, is not really the little object at all. It's the air itself, lit up and screaming as the speck rips through it, and it is happening around 80 kilometers above your head. It's happening so high, with a grain so small, that it almost always burns away to nothing long before it could ever reach the ground. What this means is that you're wishing on a mote of dust, dying of its own speed, 50 miles up. But once in a while something bigger comes through, either pea-sized or marble-sized, and then you get a fireball. It appears as a streak bright enough to throw a faint shadow, sometimes flaring green, sometimes leaving a trail of smoke that hangs in the sky for a few seconds after. And very rarely, a fragment survives the whole plunge and lands. When it does, it stops being a meteor and becomes a meteorite. A piece of the solar system you could pick up and hold in your hand, but the little grains behind most shooting stars almost never make it that far. They're too small and moving too fast. They give you the light and keep the rock. Now, where does that speck come from? If you trace it back, you'll find out the trail leads to a comet. One particular comet with a name known as Swift-Tuttle. A comet is, in essence, a dirty snowball the size of a mountain. Every time one swings in close to the sun, the heat boils material off its surface and it sheds a long stream of dust and grit behind it, like smoke trailing off a slow fuse. Over thousands of years, that debris spreads out into a vast, faint river of particles, drifting along the comet's old path around the sun. And once a year, in its own long loop around that same sun, the Earth drives straight through that river. That is all a meteor shower actually is. It's not really about stars falling or anything falling toward us at all. It is our planet moving at full orbital speed, plowing into a cloud of comet crumbs and catching them on the windshield of the sky. Every August, we pass through the trail left by Swift-Tuttle, a stream we call the Perseids, because the streaks all seem to fan out from the direction of the constellation Perseus. It's also why the show gets better after midnight. In the small hours, your side of the Earth is turned to face the direction we're traveling. You're on the front of the windshield, and the grains sweep in faster and thicker. But here's something you should really ponder about. Most of the dust burning up over your head on an August night was shed by that comet roughly 1,000 years ago. The grain that makes your wish is older than most of the nations on Earth. It has been drifting through the dark since, long before you were born, before anyone you've ever known was born. It has been waiting, in effect, for the one night the Earth would swing back around and run into it. And it ends that 1,000-year journey as a 2-second scratch of light that a person on the ground uses to wish for something small, human, and immediate. One other noteworthy thing is that the comet the shooting stars came from is not small in any sense. The solid core of Swift-Tuttle is about 26 kilometers across. To feel what that means, the asteroid that struck the Earth 66 million years ago, the one that ended the age of the dinosaurs, was somewhere around 10 kilometers wide. Swift-Tuttle is more than twice that. It is, by some measures, the largest object that repeatedly comes near our planet. And it does come near. Every 133 years, it comes sweeping back through the inner solar system, crossing the very lane the Earth travels in. For a while, that frightened the people who watched the sky. When the comet came back around in 1992, the measurements were just uncertain enough that astronomers couldn't quite rule out a future collision. A few calculations pointed uneasily toward the year 2126. So they did something quite remarkable. To see the future clearly, they went looking for the comet in the past. They dug through ancient records, like the Chinese observations of a great comet stretching back to 69 BC, and used those 2,000-year-old sightings to lock down its orbit with real precision. The answer they got was thankfully reassuring. We are safe. There is no danger from Swift-Tuttle for at least the next 2,000 years. It will pass again and again, and every time it will miss. This leaves us with something strange, though, and a little beautiful. Once a year, the Earth sails through the scattered dust of one of the most dangerous objects it has ever shared the sky with. An icy mountain fully capable of closing a chapter of life on this planet. And what that encounter gives us is not catastrophe. It is the calmest thing the night has to offer, a soft scatter of light, a reason to lie back in the grass and want something. So, why do we wish? The habit is old, and different cultures read the falling light in their own ways. To some, a shooting star was a soul, someone arriving or someone leaving. Around the Mediterranean, these very august meteors were called the Tears of St. Lawrence. After a man put to death in early August, the streaks were understood as his sparks returning to the sky each year on the anniversary of his death. But there is an older intuition underneath all of it, one that gets close to why the wish feels so natural. The idea was that the sky was a kind of ceiling, and that every so often it opened, just for an instant. In that instant, the heavens were briefly listening. The falling star was the gap. So you spoke fast while the crack was still open, because for 1 second the distance between you and whatever might be up there had narrowed to nothing. They were wrong about the mechanism, of course. It is grit and speed and torn air, but hold both pictures in your mind at once because they don't actually cancel each other out. A grain of a 1,000-year-old comet ends its life in a flash of light 50 miles above you, and a person standing under it, in that same instant, reaches for something they long for. The physics is true, the reaching is true as well, and there is no law of nature that says the second one matters any less than the first. Which brings us to this year, and to why this year in particular is worth the trouble. The Perseids arrive every August, but most years the moon spoils them. A bright moon floods the sky with pale light and drowns out everything but the boldest streaks. Last year that is exactly what happened. This year is different. The shower peaks on the night of the 12th of August, into the dark morning hours of the 13th, and this year the new moon falls on almost precisely that night. The moon will be all but gone from the sky. The dark will be as deep as the dark ever gets. It is, plainly, the best night for the Perseids in years. So here is what to do with that. On the night of August the 12th, or the early hours of the 13th, get as far from city lights as you reasonably can. Lie back. Give your eyes a full 20 minutes to adjust to the dark and keep your phone down, because the screen undoes your night vision every single time you check it. Then just look up. You don't need to find any particular spot. The streaks can break out anywhere across the sky. Be patient. Under a genuinely dark sky, and a year like this one, you might catch one a minute, sometimes more. And when one comes, when that quick line of light scratches across the black, and something in you leans forward the way it always has, you'll know exactly what you're seeing now. A fleck of a mountain-sized comet, cast off 1,000 years ago, burning up in the air above your head, at the end of a journey that began before your language, your country, your whole world took its present shape. Make the wish anyway, because it was never really about being right about the sky. It was about being small underneath it and looking up, daring to want something. If that feeling is one you'd like to have more often, the whole immense, strange universe folded up inside something as ordinary as a warm night in August, then come with us. Subscribe to Numen and keep looking up alongside us. There is so much more of this out there, and we are only just beginning.